All right, so we're going to learn more about encapsulation and abstraction today, and particularly class attributes and class methods and static methods. Let's start with a little bit of a review of decorators and getters and setters and what we learned yesterday. And actually, Landon, if you can kick us off, what I want to do is I just want to get a little help from you all, where you all are the navigators and I'm the driver. And let's write a student class and use the app property decorator to create some getters and setters for that student. So Landon, walk me through just creating a simple student class. Just
Okay.
like step one of that process.
Yeah, so you're gonna write class undercase, and then good practice is to capitalize the first letter in the class, hit enter, gets you to the correct tab spot, and then you want to define the init dunder method. So you're just going to type def for definition.
Yeah, awesome. Let me get my I can get typing, and I'm just gonna kind of go down semi-random, but calling folks on the participants list. And so Nika, now that I've got this method named init, what does it do, and what do I want to do with it to start maybe being able to have a student that has a name and stuff?
You're going to want to put things in there that would, I think the right word's attributes about it, like name and age and, well, you always start with self, but
Yep.
then name and age. And I don't know what else you wanted to add for student grades, maybe.
Yeah, I think name, age, grade is a perfect start. And what does this init method do? Why do we always have to write it whenever, or why do we almost always want to write it when we create a class?
To make sure it takes those attributes.
Close. And you can phone a friend if you want.
Oh, if anybody wants to help, sure.
I want to jump in a little bit because I kind of have an understanding, but I have a question too. So I think what happens is the Python will create a student object, and then this init method will allow you to assign instance attributes to that object that's already in existence. Now, I think if an error happens in init for some reason, that object still exists, but that's what I'm less sure about.
You're on the right path. Brian, so to answer your question, what happens is once I create a class, I can create a new instance of that class where I'm creating an object that belongs to the student class. And I do that by calling my class, and it looks a lot like calling a function, right? And the function that we call is the special underscore init method. So if I run my code and I don't have a typo, and it's complaining because I'm not doing anything with name, age, and grade, so I'll just get rid of those for just a moment, and we'll bring them right back. Notice that this print statement gets executed. Every time I instantiate a new instance of a class, the dunder init method gets run. And let's see, just kind of running down the list. And Nika and Brian, thank you. And Yams, we're passing these arguments into this init method, right? Name, age, grade. How can I make this a little more real, where like, what do I want to do with these inside my init method?
So you sort of started already with the name, age, and grade, and those are the attributes that are properties that you probably will plan to use for this class. So you can have self dot and then would you use underscore name here if you were going to do it like yesterday? So self dot name equals underscore name or name, yeah, self
Yeah.
dot underscore name.
Yeah,
equals
there is a
name.
naming convention where we put the underscore in front of something
Yeah, I did
to
have a
indicate
question.
it's supposed to be private.
Yes,
Let's
okay.
get there in just a moment. Just like, you know, any other, whenever we're defining a variable or whatever, we could name this whatever we want. So for the moment, I'll just name this name and come back to it. And you're absolutely right. We've got self.name, age.
Yeah, this is just like in a dictionary. You're just naming key value pairs.
Yeah. Awesome. And now that I've done this, I run my code, but I get this error that says missing 3 positional arguments, name, age, and grade. What's causing that and how can I fix it?
Are we still on me or is it another person? I can answer if
Oh, you know, I saw someone's hand up, so if whoever that was wants to go for it, please do. And thank you, Yams.
Okay, so for this, because the init method has name, age, and grade, which are 3 instance variables, as I understand it. When you initialize a student, it's expecting to have those 3 variables because we haven't set them as like a, I forget what it's called, where they automatically have a value. So in order to initialize a student, it needs those 3 variables to run through.
That is, you're correct and missing one little bit, which is even if I comment that stuff out, I still get this missing required positional arguments. Just like if I had, say, a function named say hi. And I called my function without passing it an argument. This is going to throw an error as well. And it would help if I had parentheses in my print statement. Because in Python, if you create a function that takes some arguments and you don't pass them, Python will throw an error. And that's true of any method that we create as part of a class as well, including this special init method. And you're totally correct then. We also want to do that because then we assign these as attributes on the instance of this class, right? On this Alice object, Alice will now have a property name, a property age, and a property grade. And Athena, yes, I saw you had a question.
I think we're gonna get back to it later, so it's fine.
I'm trying to think of ages and grades. Okay. Awesome. And just kind of running down the list of folks in the participants list. Adrian, if I want to print out Alice's name, how could I do that without changing this class at all? If I just want to print Alice's name when I run this code.
If you want to print just Alice's name, I think, would you just target like the self.name?
So I think you're on the right path, but I need, since you're the navigator, I need a little more direct guidance on what code I should write. And if you want to, you can phone a friend.
So I would do print Alice.name, I think.
Yeah, you got it. Exactly. And I apologize if that was, I didn't mean that to be a trick question, and I hope it wasn't. Right, so now that we've created these instance attributes or these properties in our object, we can print any of them. And if I create a new student, Bob's going to be like, I don't know, 10, and then I don't know what grade 10-year-olds are in. Second grade. This is, I feel like I should know this. And we print Bob's name. Right, all of our classes have this same instance attribute name, but we can give it different values for each instance of our class. Cool. And let's go ahead actually, and I think let's build out a little more and let's maybe start looking at our decorators. Oh, I apologize, folks. Let me get rid of that. And actually give me 1 sec here to look at what I want to be looking at. So let's say that we want to make this a little fancier, and let's make a getter and a setter for age. And maybe Albert, could you walk me through step 1 of creating a getter on our student class for age?
So we need to start with a decorator, right? So we could do property.
Yep, nice. And then what's the next step? And feel more than free to phone a friend.
Yeah, I can't remember right now.
Okay, who do you want to phone?
Let me know. Could we try, yeah, James?
Sure. So after you add that decorator, you want to define a new method. So you could call that like get age. And then, yeah, that needs to take in self. And then we want it to return self dot age, I believe.
Awesome. And James, if I want to print out Alice's and Bob's ages using this decorator that we just wrote, how would I do that? Not a trick question.
Yeah, I'm not totally sure, but could we can I phone a friend?
Please, you can always phone a friend.
Yeah, Terrence, go ahead.
I think you would type in print bob dot get underscore age. Would that work?
Let's give it a shot. Yeah, awesome.
Perfect.
And actually I'll do this for Alice as well. And can anyone predict what happens if I try to access age without using my getter for Alice when I run this code?
Brett, you got your hand up?
Yeah, I was gonna say it's gonna tell you that you can't access that because
I thought it
no.
would have actually done
Yeah.
that as well. It definitely does that sometimes. I might have been a little confused, to be honest, so I apologize.
Is it because the initial class isn't a property?
Say that again.
Is it because like when we first declared like self.age equals age, like that's not a property? Above that line?
No, I'm not sure I understood the question, but I
That's
don't
fine. It's fine.
think so. Yeah, I'm not actually sure why. And this one's actually a little less important. Tom, yes, sir.
I was gonna say, kind of like we reviewed yesterday, like I don't like because there are no um private or public like private publics what do you call it attributes for like instant attributes or methods, like wouldn't we use the getters and the setters for like specific, like, okay, let's like if grade was stored as an integer but you wanted to return it as a string, we could use like get grade but then like append the string and like th and it would return it in like ninth. But like if we got self dot grade, wouldn't it always return grade? Or
Yeah, you're on the right track, that we can use setters to implement different behavior than directly accessing a property. And let me quickly make one change here, which Yams, you had pointed out earlier, which is a bit of a Python naming convention, which is when we are using the at property decorator to create getters and setters, we do want to make it easy for other programmers to see that that's the intent of this code. So when we're creating these class instance variables, if we want other programmers to access it by using a getter and a setter, the convention is to name it starting with an underscore. So self underscore age. And let me go ahead and make that change here. And I'm going to run my code to make sure that it works. And I am curious about one thing real quick. That still works. Yeah, there's like an extra naming convention, I think, where you can sort of get private stuff, but not really. And Tom, I really like your idea. Let's build out, actually, why don't we build out a getter and a setter for grade along the lines of what you were describing? And can you maybe get me started with that process?
Just real quick, we
Sure
got a
thing.
couple hands up.
Oh, thank you so much. Let's
Terrence,
see. Yeah, Terrence. Thank you, Kara.
I just wanted to clarify. So can we basically access a property directly or with a getter method until an attribute is made private, then it's only accessible via the getter? Is that how it works?
You can access it directly both ways. That's correct. Python sort of lets you create private variables, but there's a way to get around it. They're not really private, so we don't go that deep into it. There's yeah, there's not really like other languages like Java, you can do something like you could declare it wouldn't look exactly like this, but it might look like this. And then you literally can't access that except outside of getters and setters. But there's not a way to do that directly in Python. So it's more about communicating like intent to other programmers. So you're correct that we can always do Alice. If we want to, we can do print Alice.age. Does that help a bit? I know it's a little confusing because it means there are two ways to get the same thing.
It helps. Thank you.
Yeah, totally. Athena, yes.
So I was going over the stuff with a TA and there was like 2 underscores and that made like
Yeah,
is that the same thing or is it different?
it's a little different. That is like as close as Python gets to private variables. If I name something with 2 underscores, here, let's see what happens here. So, first off, let me make sure that I got this right. Yeah. So if you name an instance variable with 2 leading underscores, it's not fully private. I think it's called name mangling. As you can see, this works fine. This works fine. But when we try to access the property directly, it throws an error. It's not worth going into right now, like the details of this, because there's a way to get around this and still access this age property anyway. I would not worry too much about the 2 underscores since it's not like a true private method anyway. Yeah, it's called name mangling. And to be honest, I wouldn't worry about it too much. But it is there, and to be honest, it's a little confusing because it sort of depends on this magic behavior, which is part of why I tend to avoid it. Brian, I see you have a question as well. If you could throw it in the chat, actually, that would be awesome because I want to make sure that we're able to get a little more code on the screen and then move on to looking at a bit more with class methods and stuff. And Tom, I thought you actually had a good idea of building like a getter and setter around a grade and storing it in one way and presenting it in another. So could you maybe get us started on that process and talk me through about maybe creating let's create the getter for grade.
Good thing. So for the getter, we want to define another function with the app property decorator. That way it signifies to the class that it is a getter. And then in that function, we can set maybe like a variable called grade num equal to self.grade. That way we can grab the number, or we could actually, that's kind of inefficient. I guess we could just return well, no, so yeah, so that I think would work, and then we could typecast the grade, the self dot underscore grade to a string. That way the grade num could be a string. And then we could return an f string with grade num in brackets, and then append like a and then append or yeah, th. That'd be perfect.
It's voodoo handle and I'll leave kind of fleshing this feature out as a to-do. And I'm going to add a little multi-line comment here to just indicate the different args. There's a better way to do this in Python, but just to get the ball rolling, I'm going to do it this way. So the intent being now, in fact, here for 12th grade, let's pass in 12. Or for second grade, let's pass in 2. And now if I print Alice's grade or Bob's grade, then now tooth is not right. So we need to fix that, right? But this are using the pattern of getters and setters. We can take in a grade as an integer, which is nice because that's actually the better way to store that piece of data. But we can present it to the user as a string, right? With some additional formatting. And just kind of running down the list here. Andrew, Duke, can you maybe walk me through creating a setter to set age? Or I'm so sorry, for setting the student's grade, if you want to change the grade that they're in.
So for setting it, I believe you do at setter dot get grade is your decorator. And then you would have the definition of your function to actually set the grade. So I think for us, we did set underscore grade self. And then we need to include what we want the grade to change to. So you can make that a new grade parameter.
Nice. Okay.
And then at this point, you would change or make self dot grade equal to new grade. Unless I've missed something.
I think you've almost got it. There's a red squiggly here. This syntax is almost right. I believe it should look a little different.
They're just backwards.
Yeah, you just flip flop it.
Yeah, so you had the right idea. The syntax is the getter name and then dot setter. And Andrew, actually, can you take us home here, and how could I use this setter now that we've created it to change Alice's grade?
Okay, so for that, you would want to try Alice dot set grade, and then parentheses the new grade you want to set to.
Oh, I'm so sorry. Let's try actually running that code. So I'm getting this error, string object is not callable on line 39. Can you help me debug what's going on there? And as always, you can phone a friend.
So from what I understand, it's not sure if that is an integer when it's asking for an integer to set the grade in that property. So I don't know if wrapping new grade in parentheses with int would fix that. And if
So-
that's not it, I'm out of ideas.
Yeah, I see where you're coming from, because this type error does say string object is not callable. That's not quite the source of this error. Terrence, I see you had your hand up as well.
I think it means that we're not supposed to call it like a function, and we should do Alice dot set underscore grade equals new grade.
Yeah, Andrew, you were almost there, and this is, I think, one of the confusing bits about the getter setter syntax. And maybe we do need to change how we show the naming conventions for this. But once you create a setter, the idea is just like any other instance variable, you would change it with by using the equal sign.
Yeah, I actually got stuck doing this yesterday for a while, trying to figure out why I was getting that string error.
Yeah. And that is definitely, I think, a little bit of a gotcha with getters and setters, especially because it's the error message isn't gonna it's not super intuitive what the meaning of that is. So that's, I think, just a good one to file away. But you took us like almost all the way home, so that was awesome. And thank you, Terrence. And so now we've got a getter and a setter. And if I wanted to, I could do something like if new grade equals 0, print must enter valid grade, else, right? I can start to add validation logic here. And that can be part of the advantage of using set grade. I think what we can do, by the way, is let's see if that works. Yeah, so there was a really good question earlier about like, well, hey, I can write a setter with validation logic, but then in my constructor, we're not using it. You can actually use, I think pretty much any class method that you create, including getters and setters inside your constructor. So like over here, if we change this for Alice's age to be 0, we should see our warning message. Yep, and we get must enter valid age. Now this can be a little dangerous because now, and I'm so sorry, this must enter valid grade, excuse me. This can be a little dangerous because now Alice doesn't have a grade at all. This is set probably to null, I want to say.
Still
So we
prints
have
a
to be,
0th.
sorry.
It still prints a 0th.
Oh, did it still?
I think because we were running into this issue yesterday. Because
Yeah.
it'll still set the self.grade to grade because it'll just overwrite that set grade.
Yeah, let's try. Thank you so much. I may have had my syntax wrong here. Must enter valid grade, Alice get grade. There we go. I think let's do this. Let's have self grade equal none. so that it's set to something so that we don't get errors. And let me try this again. And thank you, Kara. I may have gotten my syntax wrong there. So we have none, right? And then actually we can go ahead and we could do if self dot underscore grade equals none. Return self underscore grade, or we can just return, we'll just return a big message saying no grade. And now with my getters and setters, and Kara, thank you again. I totally had the syntax wrong there. We just use the setter like normal inside our constructor. I was adding this step that we don't need. And now with our getter, we can handle if a grade doesn't exist. Like instead of no grade, we could have thrown an error or returned none or done a bunch of different things. And we can add some validation logic with our setter. And we can see how we can, if we want, use our setters and that validation logic inside the constructor itself. So I just want to check in and see if folks have any questions around how to kind of implement getters and setters the way that we've been going over. Natalie, yes.
So would you say that's a better way to do things, is to put the setter under the init?
It depends on what the setter is doing, and it depends on how we use this. Like sometimes there might be a good reason why we don't want the validation logic in our constructor. It really just depends on the situation. But a lot of the times we may always want to use that validation logic. So it's if you know that every time you create a student, you want to check to make sure that the grade is valid, and you have that validation logic in your setter, then it would make sense to use the setter. Yeah, I know that was not a direct answer, but I hope that helps.
Yeah, I just didn't even know you could do that. So
For
And if
sure.
I
you
hadn't
wanna
thought about
do-
that.
Sorry.
Totally.
And if you want to do the validation for stuff like that, do you always need to do it in like a setter function rather than just like a regular
No,
function method?
you could totally write a validation function if you want, and you'll see that often as well. For instance, we could write a function named validate age, self age to validate. I mean, if age is less than, I don't know, 5, print age invalid. It actually, the validation functions, depending on what pattern you use, it can be a little funky, because like if I was doing this, what I would do here then is I would do if self validate age, or excuse me, this really belongs in, well, let's create, it depends where we want to use this. Actually, we could use it here, right? I could say if self validate age is true. Or I don't think we had a getter for that. We did actually. Right. And so there's a lot of different patterns for writing validators. Note that here, the reason there's sort of this extra step of returning true or false is because I'm following the single responsibility principle, where this method's only job is to tell me if the age is valid or not. It's not its job to update my class instance variable. that's something else's job. And then, you know, if we were doing it this way, maybe we have and like we duplicate this logic again. On a practical level, it probably makes sense to put your validation logic in the setter, especially because we want you to practice getters and setters. But there are absolutely times where this is a good pattern to follow. I see a couple questions. I don't want to go too deep into this validation stuff because I want to make sure that we can cover some other things with class instance variables. If it's something that's not related to getters and setters, could you please maybe just throw it in the Zoom chat or the whiskey chat?
Mine is related.
Yeah, what's up? And thank you.
Kind of goes back, it kind of goes back to the question that I had earlier. But so in this example, you did mostly what I was asking about earlier, where now we're using the setter in the constructor. But if we're going to use the setter in the constructor, would it not just make more sense to name the getters and setters set or self.grade and then just, or not name the getter and setter just grade? And then in the constructor, you would just do self.grade.
Right. You're basically saying, hey, instead of naming our setter set grade, let's just name it grade. And instead of naming our getter get grade, let's just name it.
Yeah, exactly. And then you don't have to worry about like, do I need to use the setter or the getter? It's going to do that automatically. And then you just know if you want to bypass the getter or the setter, then you would just use self._grade.
Yeah, we may need to update our curriculum and assignments, to be honest, because this is the pattern that you'll often see in the industry. My thinking was that, like, especially when we're introducing this, my hope was that the explicit names would make it easier to see what's a setter and what's a getter versus a normal instance property. But you may be right that that works a little better in theory than in practice.
And then I have a quick side note for assignments specifically, when the test cases are given, at least on the student registry one, the getters and the setters were pre-named get age or like get age and set age. If we were to use a different getter and setter name, it would fail. Would we be allowed to change the name of the getter and setter in the test file? Or like
no,
we would have to use the same one.
You got to use what's in the tests and the spec, and that's for a couple reasons. The first is on a practical level, it's just going to cause too much confusion if we have people like modifying those tests. That's something that I think we have to just update and then have it be the same for everyone. The second one is the reality is that when you're writing code professionally, like you often have to write code to spec. So even if maybe we need to change this, to be honest, it is a good thing to learn. And when we get to Django later, you'll see that like for project structures, certain things have to live in certain directories and certain methods have to be named certain ways. So it's a good skill to practice as well.
Cool. Thanks, Adam.
Yeah, no, it's a good question. And we might need to revisit that one. But now that we're kind of like in process, changing those tests is gonna cause more confusion than it's worth. And we definitely will, like when we sort of do our team meeting at the end of the week, we'll kind of revisit this and see if we need to update this in the curriculum. Let's take, why don't we take 5 and then let's dive into looking at like class instances and class objects. Actually, because I want to make sure we have enough time for work time. How are folks doing? Do we want, let me go ahead and pause this as well. So The next thing that we're going to kind of cover today is what's called class attributes or class methods. Instance is when I create, an instance of a student, right? Alice is an instance of the student class. And everything is an object in Python. So the Alice object is of type student class. Bob is a separate instance of the student class. And our instances can have attributes, those properties that we've defined, and methods, right? And getters and setters are sort of these special methods that let us treat them like methods, like attributes. And it turns out that we can give attributes and methods for the whole class as well. And one good analogy to use to think about this is if you are in an office building, or for those of you here in the classroom in the WeWork, each office in an office building is going to have some differences, but it's going to have the same pattern. And you could almost think of that as different instances of an office, right? Every office might have a desk, it might be the same size, but there will be a different person in it. The office will be on a different floor, it will have a different floor number. And those are all instances. But then in the building, there's some things like, say, the cafeteria that the whole building shares and there's only one of. And that's sort of like what a class method is. It's all the different instances can use it, right? Everyone in a building who's got their own office can go to the cafeteria, but it's this one shared resource amongst the group. So class attributes and methods can be accessed by all instances of a class. And instance attributes and methods, well, all instances have them, but they can only access and change their own, and it only affects themselves. While with class attributes, if it changes for all instances of that class. And let's go ahead and write some code and see what that looks like. And as I dive into it, we'll get a couple questions going and a little interactivity. So I'm gonna write some code and then we might do a little importing as well, just to kind of review that. But let's just go ahead and write a dog class. And we'll give it an init method. I'll get rid of this type hint stuff that we don't need to worry about. And as we've sort of reviewed from this morning, I can give my dog a name. I can give the dog a breed, what kind of breed of dog it is. It would sure help if I actually pass those as arguments. And that's where those red squigglies are coming from. If I hover over this, name is not defined because it isn't an argument for my constructor yet. And I'm not going to worry about getters and setters right now. And I can create a couple dogs, right? And I can, look at information about those dogs. And I'm going to go ahead and run my code and make sure that it's all working. And this is what we've started to become familiar with creating classes. Kara, I love it. Yep, some of us have real dogs. Indeed, who let the dogs out. So we'll come back to dogs in a minute, but let's use another class as an example here. Let's say I want to make a class for we're going to deal with geometric shapes, which is another dogs, animals, cars, and shapes are the three classic things that people use to learn object-oriented programming. And my circle class is going to have a constructor function, a dunder init function, and we're going to pass it an argument, radius, and we'll set it as an attribute on each instance of that class. And maybe I don't know, maybe I want a method like get area or something like that. And it's going to return self dot radius times pi, right? To get the area of a circle 3.14159. But I think it's pi, what is it? Pi r squared. So it would help if I got the order of my operations right. So I think it should look something like this. And I will put this in some parentheses. I think that syntax works. We're about to find out in a moment. And let's just give it a radius of, I don't know, 4. And print my circle dot. We'll get the area. And I'm not using getters or setters or anything like that right now. And actually, can someone maybe remind me in Python? Well, let's try adding the multiplication symbol and see if that does it. There we go. So more or less now, I can make a circle and I can figure out its radius, right? And I can make another circle. And I can get its area as well. And let's say, just for the sake of argument, that our code is starting to get more complex and I want to run this in a different file. So maybe we want to import our circle class. And I want to do this work over here. And so now I want to run my runner file. That runner is just sort of one common name you'll see sort of for these like main files that actually execute the stuff. Right, and this is how I want to organize my code right now. So let me introduce a class attribute, and we can talk about what it is. Every instance of my circle class has access to this, and it's on the class itself. And this lets us do a couple interesting things. First off, let me just go ahead and comment this stuff out. First off, this is created for every instance of every class, but it belongs to the class. So each instance can use it. What is also kind of interesting is even if I didn't create any class instances, just by importing the class, like sort of the blueprint, I have access to this. So you often will create class attributes for things like pi, because maybe over here in my code, like I'm doing stuff with circles, but maybe for some other reason, I need to just be able to like print out what pi is or use it somewhere else. So it can be helpful to keep stuff organized with class attributes, because it kind of makes sense that we would want to store the value of pi where we kind of store how to calculate, the area of a circle. And maybe I add a method for getting like, oh, what is isn't there another diameter method, 2 pi r or something like that?
Circumference.
Circumference.
I think it's-
Circumference. Thank you so
Yeah.
much. That is the word that I would be looking for. right? Maybe I want to get the circumference of a circle too. And it would help if I still was creating these circles. Let's just comment that stuff out. And I think you all are seeing where I'm going with this, which is like, hey, we have this important constant hard-coded in our code in 2 different places. And it'd be nice if we didn't have to do that. And that's where class attributes can be useful as well. Because now what I can do is also inside the class, I can access it. And let me make sure that I am doing this with the right syntax. And apologies, give me 1 sec here. So it's interesting. I think we can do it like this. We can probably also do it like that. I'm actually kind of curious to see. Let's do a quick sanity check here to see if I'm confused. Yeah, there's multiple ways to do this. I would recommend the self.py because I think it's a little cleaner and you can tell what's going on. I'll double check around best practice for that. But for now, let's stick with this because this is also like what we're used to seeing. Let me actually just quickly double check here because to make sure that I'm not taking us down the wrong path. Yeah, I think this is good for now. I'll follow up if we want to tweak how we do this. But I can define this once as a class attribute, and now I can use it everywhere. And you know, like, yes, I could have done self.py equals 3.14159, but it doesn't let me do this, say if I need pi for other things. And also, again, this is in part about communicating intent. This is never gonna change. So it kind of makes sense for it to be a class attribute, right? Here's like the stuff that's maybe different for each instance of our class. But if there's something that's the same for all instances of our class everywhere, then it probably makes sense to have it be a class attribute and not an instance attribute. Terrence, yes, sir.
I just wanted to clarify, are the terms class attribute and class variable interchangeable?
Yeah, great question. You'll hear people say instance variable or class variable, and it's interchangeable with instance attribute, class attribute. Sometimes you might hear like someone say like a property on, you know, the school class or something like that as well. So there's a lot of similar-ish terms that all mean the same thing, and it can be a little confusing. Yeah, great question. Thank you. Let me throw in another example here so that we can see it in action a bit more, and then we'll keep on going. Give me just 1 sec here. And let's actually, I am going to make a change. I think, and I apologize for the confusion on this. I think what probably makes more sense is like when you're accessing or using a class attribute inside the class, do it this way with the class name, because this way when we read the code, I can tell that this is a class attribute. So this is what I would recommend when you're using class attributes inside a class, because this way I read this code and it's way clearer. So I'm sorry about the confusion there. Let's go
Tom's
back.
got his hand up real quick.
Oh, thank you so much. Yes, what's up?
Just a quick question. For Python, like in your experience, is it a normal convention to like put constants in all caps when you define them, or do they leave them lowercase?
It is. Like this would be
Okay.
the best practice in terms of naming a constant like this is it is constant should be all caps. And that's a
Okay.
convention in a bunch of programming languages.
Thank you.
Yeah, totally. Mainly, I just
Nat-
didn't want to throw something extra into the mix that might cause confusion. Yeah, I think someone else had a question as well.
Natalie and Athena have questions in chat.
Thank you. Let me catch up on the chat. Natalie, I see your question there. Yeah, so good question. Because there was two way of doing things. I don't know if I don't think this will work. Let's actually find out. That's a good question. Yeah, Python doesn't like that. Like Python is thinking it looks for pi as a variable defined within this method, and then when it doesn't see it, it freaks out. We do need to tell Python where to go to find this variable, and because it's a class attribute, we need to tell Python, hey, you should look at this class to find the class attribute. So the way you should use class attributes inside a class is class name dot the attribute name itself. Yeah, good question. And Athena, I can't find your question in the chat. What was on your mind?
They have the same question.
Oh, perfect. Yeah, thank you both. And Kara and DJ, class presidents, thank you very much for helping with the questions. So let's add some class attributes to our dog. And actually, could someone maybe help me out with this? And let me actually go from sort of the bottom up from the participants list. Actually, let me bring back. I don't know why I got rid of this. Let's leave this here as some reference code. Will, I want to create a class attribute for dogs for how many legs they have. Can you navigate me in adding that to our dog class? A class attribute with the number of legs that every dog has.
Right. So assuming that all the dogs have 4 legs,
Yeah.
you can just inside the function init, you just put self.leg equals 4.
So is this an instance attribute or a class attribute?
That'll be a class attribute.
This is actually an instance attribute. When we define like a variable or an attribute when we're creating a class with self dot something, we're saying, hey, when you initialize this instance of the class, set self dot legs to 4. And the difference is this. Let's just say I make a method named change legs, and let's just call it like num. Just to get something really simple in here, dog2. Or actually, we don't even need to do this. I don't know why I was going down that road. I could just do dog2 legs equals 7. There we go. So I create 2 dogs. Each instance of the dog's class, when it's created, when it's initialized, has an instance attribute named legs that's set to 4. But I can go ahead and change that just for one of my dogs. And now one dog has 4 legs and the other has 7. And yes, Kara and Will, I think you mentioned this as well. this does raise a good point. Like in the real world, there are a lot of edge cases. There are a lot of three-legged dogs out there, and we would want to include them as well. And that's where, you know, if you were writing this code for real, you'd have to think about that. But for our purposes, we're keeping it simple. So how can I, instead of an instance attribute where legs might be different for different dogs, create a class attribute so that all dogs always have 4 legs until the end of time, unless we change it so that all dogs everywhere have 9 legs until the end of time, but it's true for all the dogs, and it can't be changed for one particular dog. And Will, you can, as always, phone a friend if you want to.
I think Wes raised his hand.
Go for it. Yeah.
Yeah, I was just gonna say you could do a class attribute, I think it's called. And just say legs, like right under class dog, you could just put legs equals 4.
Yeah, exactly. So the same way that with my circle class, I create a class attribute pi that's going to be 3.14159 for every instance of the circle class. I'm going to do that for dogs, and I'll uppercase this in a minute. I just want to drive the point home. There's nothing special. There's no magic happening with these names. And now let me save this and let's run this code and we can see what happens. A couple of things will happen. So first off, this just gets skipped because this doesn't even oh, we're creating it on there. So yeah, let's. So this does raise an interesting sort of edge case point. Like Python gives you a lot of flexibility. It is probably a good idea if you want to directly access a class attribute to do it off the class itself. Because, and let me, oh, I'm so sorry. I've been running the, I jumped around a bit between running the files. I'm sorry if that caused any confusion. So, like Python is flexible. I can create an instance attribute on dog2 named legs. And note when I print out dog2 legs, that's actually what Python goes to, and it overrides that. But the dog class still has this class attribute legs that is still 4. So there is a little bit of subtlety here. And so just like we saw where within a class, if I want to access a class attribute, do it by the class name dot attribute. If you need to use it like outside the class for any reason, do it that way as well. For simplicity and safety, to avoid like possible edge cases or confusion. And as someone mentioned, the convention is for constants, for variables that don't change, to be all uppercase. So I would name it this way, but I just want to make sure everyone understands that there's no Python magic happening based on whether we have the variable named with caps or not. And so, in fact, most of the time, you probably wouldn't want to do like dog1.legs, dog2.legs, because if it's a class variable, it should be true for all instances of the class. So let's just check the class itself. Now, you know, if I want to make a method, it's like how many legs I can return that, and I can print that as well. And for dog2, it will have 4 legs. And let me kind of run down sort of our participants list here. And Tyler, help me out. Let's create like a species class attribute for dog, and then let's create a method like describe dog that uses the species and the legs to print out information about the dog.
Do you want to modify the species for each instance of dog, or just
No,
like
I want to make a
specific
class
dog?
attribute that's going to be true for all dogs. And we can just
Okay.
call it dog if we want. I'm not worried about the actual correct species name.
Okay. Then I mean, yeah, you could just have below legs. You could have species equals whatever you want for the species. And then you wanted a method to access it.
Yeah, I want to describe dog method. And let's say that I want to know the dog's name, the dog's breed, the dog's species, and how many legs it has.
Okay. Then you could just return a F string, insert, and however, my name is bracket self.name.
Yeah.
I am I guess, I'm thinking of, species and breed. I guess there's only one. How many different types of species of dog are there?
I think just one,
self
but
dot.
I'm not 100% on that either, to be honest.
Okay,
But
yeah.
for our purposes, there is one species of dog.
Yeah, dog duck species, and I have dog dot legs.
Yeah, exactly. And there is a great question about changing a class attribute. And indeed, we actually can do that. So let's go ahead and let's do let's describe our dogs. And it looks like I'm just missing a closing parentheses on my print statement. So we've got two dogs. They both happen to be Labradors. Great question. What happens if I do dog.species? Now, if you see a variable name, whether it's a normal variable, a class attribute, or an instance attribute in all caps, that's the programmer telling you this is not supposed to change. So if we actually wanted to be changing this, we wouldn't have the name be in all caps. But for learning purposes, it doesn't matter. And again, there's nothing magic about the all caps. Let's see what happens. And put that there. And sorry, I jumped a bit too far down to the circle. So when I run this, what do you all think is going to happen when we get to these print statements on lines 22 and 23?
There'll be space dogs.
I think so. I hope so. And indeed they are. And note that I changed this, and that change is for all instances of this class. And that's sort of like the power of class attributes. And we can have these be lists or variable or dictionaries as well. Maybe I mean, it wouldn't make sense for all dogs to have the same toys, but just for the sake of argument, just to have something to look at, I'm going to do that right now. So they get a stick and they get a ball. And now if I print dog toys, right? Maybe I want all the dogs to have another toy. So dog toys, what is it? Append. How about Frisbee? right? So a class attribute, just like an instance attribute, can be a list of dictionaries, a dictionary of lists. It could be another class or an instance of another class. You know, just like any other variable, we can use all the features of the Python language.
Hey, real
So,
quick, Adam, looked like Saul had a question.
oh, thank you so much. Yes, what's up?
Yeah, I just wanted to make sure I heard you right. You said that the class attributes, they're capitalized to let us know, it's not, we're not supposed to be changing it, but it's not a immutable variable, right? Like
That
it's
is
not locked
correct.
in.
Python doesn't really have the concept of immutable variables. I don't think there's a way in the language, at least any useful way, to say this variable cannot be changed.
Oh, okay, sounds good. I just
Yeah,
want to make sure I heard that right.
totally.
Thank you.
Like if you see, you know, like an example, like this is what I mean. I'm just I don't know like all the states, but I don't know Illinois, Arkansas, California. You know, if I saw this, let's just make it state abbreviations. If I saw a list in all caps like this, what's another state abbreviation? Hawaii, is that right? I would
Yes.
know, yeah, that this is a list of constant values that is never ever meant to be changed, right? And this is a good example of when programmers and people would just say, oh, this is a constant. And we're trusting other programmers not to mess with this. And that's also where tests become useful to make sure that this stuff doesn't change, because then the code would break. So you can have any you know, you can put any variable or any instance attribute or any class attribute that you want in all caps. You're just telling other programmers this is not meant to be changed. So like for this dog class, if you are working with this class, if you are importing it, right? And so instead of maybe having all this code be over here, it's over here. And it's not dogs. Note, by the way, grayed out telling me it's not used. Red squiggly telling me it's not defined. VS Code hinting that I have the name wrong. So I'm using this class that you wrote. I'm not gonna do this because I can tell with the all caps that species isn't meant to be changed, but it's fine to add more toys. Mike, yes, sir.
Oh, I think you just described it right there. It was just because class won't necessarily always be all caps, like in the event that you update it. So like normally maybe it would, because it would apply to everything, but if it's something you're updating, like the cars example is like you have the running log of cars, or like you're going to update the list of all the cars you have, then you would just by convention have it lowercase, just to show like, yes, this is a class attribute, but we'll be changing this.
Correct.
Okay, thank you.
Yeah, Tyler, what's up?
And also,
actually, guys, I apologize. Please throw your questions in the whiskey chat, or in Zoom chat, because I want to make sure we have enough time to break and dig into the exercise. So let me quickly show the exercise that I want you all to spend, like take a 10-minute break and then do spend 20 minutes getting started on this so you can get this under your fingers a bit. So let me go ahead and show this real quick and walk through it. And Landon and I want to say maybe it was Brian. Once we break, I'm happy to answer your questions. So the assignment here is car management. We want you to create a class called car manager and pretty much walk through this sort of guided coding exercise to create some class attributes that we are going to change. We're going to have an attribute that is a list or dictionary that will store all the cars that we create. and a class attribute that is going to be like an integer that's the total number of cars. So every time we create a new car instance, total cars is going to increase, and we're going to want to update this list to have all of the cars in it. We're also going to have you create a bunch of instance attributes and getters and setters for them. And then we want you to also build a terminal application to start working on this. So I realized, because I went into sort of the work hour, that we might not get to the full Megillah, so to speak, the whole thing. So start with the class definition and, write a little code to make sure you can create a car and that stuff is working. And see how far, if you can get into the terminal application stuff, and we'll do a review of this maybe either at the end of the lesson or after lunch. Do folks have any questions about this assignment? Cool. Okay. Take a short break. Please do make sure you spend some time writing code on this. And we'll reconvene at let's say 11 o'clock to look at class methods, where we can write methods that belong to a whole class as well. Let's take a look at this car management system exercise and talk a little bit about it. So let me talk a little bit too about kind of how to tackle this stuff, because there's a lot of steps here, and I realized we didn't have the full hour. My intent, and I hope that folks focused on the part with the class attributes. And you will have more time to work on this. It's always a good idea to think a little bit about like your process of what you want to start building. So as I'm looking through this whole thing, and I kind of give the whole thing a skim, I see that I need to make a class named car manager. I'm just going to go ahead and do that right now. And I know that for almost every class ever that I make, I'm going to need a dunder init function. So I'm just going to make that now too. And we're not even using it for anything, but I'm going to add that bit of code just so I can run this and it works, and I know I don't have any typos. And I see that it's asking me to make these following class attributes: all cars, which is going to be a list and a dictionary that stores all the car instances created, and total cars, which is an integer that keeps track of the total number of cars. So we're creating two class attributes, and they're both going to change. All cars sounds a little more complicated, so I'm going to start with total cars. And what should the default initial value of total cars be?
0.
Yeah, exactly, because we don't have any cars yet. And now for the constructor, it's asking me to create all of these instances. ID, make, model, year, and so on, and then a terminal application, and then there's a lot of functionality. So I'm going to kind of do a little project management decision making here and decide I'm not worrying about the terminal application until I get most of this up and running. This functionality step, it's basically saying like make the menu real. So I'm going to worry about this stuff later and focus on this stuff. And I'm going to focus just on ID, make, and model, because those are the most important things. And also with that, I get most of the interesting stuff I need. So it's asking me to pass this ID instance attribute. And actually, would anyone like to volunteer to maybe do a little group coding navigating and navigate me towards creating this ID attribute? Chris, yes, sir.
So we'll start under the dunder init. What I did on mine was self dot underscore ID. or oh, my bad. Start, yep, underscore ID equals.
Something like that.
At first that's what I did. And then I remembered that we have, or for every car instance, we want to add onto it for every new
Okay.
entry. So
Yep.
what I did was, instead of equals ID,
Mm-hmm.
what I did was car manager, the class, dot, total cars,
Love it.
and then +1.
Like that.
Yep. And then the next line, which also pertains to this, is so that we can also change total cars as we change the ID. What I did was car manager dot total cars, then plus equals 1.
Awesome. I love it. And let me go ahead and let's create a couple cars and see what we've got going on. So got 4 cars. Let's do a couple things. I'm gonna want to print car manager dot total cars, and I'm just gonna stick that after each one. And I think what I'm gonna do too is Chris, as you pointed out, now that we've made this Dunder ID method, let's print out car1 dot Dunder ID, and let's do this for car2. And let's do this for car3. And let's do this for car4. And let's run our code. And yeah, I like this approach, Chris, of we've got this class attribute and we know we're always going to be incrementing it. So why don't I just use this as my ID? And I think that makes a lot of sense. So, and actually, I think what I'm going to do too is print. Just going to add a little bit of a, so I can tell what's what, because I can already tell I'm getting a little confused. So I see that total cars is 0. And actually, let's do and we'll make these print statements even a bit better. And what did it not like? It would help if I added a plus symbol. And of course, it would help if I didn't have that typo. Sorry about this, folks. If nothing else, hopefully my debugging workflow is useful to see, though that was not the intent. And I probably have confused some Python and JavaScript here can only concatenate string, not int to string. This is actually a good debugging moment because the type error is telling me what's going on. Total cars is an integer, but I'm trying to combine or concatenate it with the string, and Python doesn't like that. So I can use the Python built-in string method. That should be able to cast that integer into a string. And now we're cooking and this is working. And I should have just tested it on 1 from the get-go and taken my advice of always run your code. And we could have gotten there a little quicker. But now I have some better data that I can see. So total cars is 0. We create car1. Car1's ID is 1. Total cars is 2. We create car2. Car2's ID is 2. And so on and so forth. Yeah, Chris, I think this works great. If we wanted to, what we could do is put this after this and get rid of the +1. And then let's see what this does. So, or actually maybe we could do it that way. We could do it that way. If we do it this way, the first car's ID is 0 and the car ID matches the count. I don't think the problem specifies like if we need to do one approach or the other. So I don't think there's necessarily a wrong way here. There's something to be said for an ID not necessarily being 0. I just wanted to kind of point out some design decisions and options around this. Chris, thank you for kind of navigating me through this. We have the most critically important piece here, which is that I now have a class attribute total cars for all my cars, and it updates every time I create a new car. And I know a couple folks were asking about what's a good way to do this. And this is where the constructor is our best friend, because what happens every time I create a new car, we call the constructor function, this dunder init. So it's a great place to update total cars. And Chris, as you pointed out, the quickest and easiest way to get an integer that should never be repeated and only rise with each car instance is to just use that count as our ID. So this is awesome. And I want to check in to see what questions folks have around this, specifically on creating this total cars attribute and our ID instance attribute. David, yes, sir.
Yeah, my intuition is that this would be redundant, but you wouldn't want to set ID also as a attribute within the parentheses after the init method, right? Like it's defined within the function itself, right? Like you don't have to specify that it's an attribute. Is that correct?
I'm sorry, do what with ID after the init method?
Yeah, so within the arguments within the init method, eventually you're going to set up like make, model year, mileage, etc. Because you defined ID through car manager, you wouldn't want to include that as an argument within the parentheses as well. Is that correct?
You might have to be a little more specific. I think you're asking if I have some method like set year or set ID or something like that. I'm not quite sure, but the short answer is
I'm sure it'll be answered through as we go through this. Yeah, I'll just get offline now. Sorry.
No, it's all good. And I apologize if I got a little confused there. I think the short answer is this is all we need, because as you correctly pointed out, we have created an ID that meets all the requirements for each individual instance of the car.
Here, I think I can understand the question. So, I think he's asking if we should put ID as like an argument, like after the dunder, like, like in it, and then within the parentheses. The reason you don't want to do that because you're giving the option for the user to input an ID, but in the dunder method or in the constructor, it creates that ID, so it allows the user to give an ID when you're already creating an ID, which is what you don't want. So you do not want to put ID within
Got
that
it.
argument.
Thank you for
Chris.
explaining that.
Yeah, that helped.
Yeah.
Thank you, Chris.
Yeah, exactly. We do not want to do this because, as you guys pointed out, we want to be able to control how this ID is generated. We don't want the user to be able to modify the ID, so we don't want it in the constructor. David, that was you. Awesome. Would someone, as long as we're doing this, maybe like to navigate me a little in creating our total cars class, or I'm so sorry, our all cars class attribute? Would anyone like to volunteer to maybe just even get the ball rolling on this? Tom, yes, sir.
I thought about making. I'm in mine, just like outside of the constructor, just right below where we define total cars.
And Tom, I'm sorry to interrupt. What I would love is, can you navigate me in building it?
Okay, yes.
Thank you.
So for underneath total cars, I would define a list all cars and just make it an empty list right now. And then at the end of the so right after the self._id, we could update or we could
Right.
append the car to the list, maybe like the car ID. I wasn't sure. I actually kind of had a question on this. Would it be relevant here to maybe make like append like a dictionary in there with all of the car attributes?
That's a great question. Let's take a look at what the assignment is asking us to do. So it's asking us to make like a list/dictionary, which tells us that this might be a
Oh.
bit of a fancier data structure that will store all the car instances created. So it does
Okay.
leave it a little open-ended. What you have here, by the way, is I think a great prototype and starting point, and also gives us some very testable code, right? I can test to make sure, and let me add some comments here. Right, update total cars and create ID for this car. Update all cars. And we can have some very testable code now, right? And in fact, let's go ahead and let's just print below here, let's just print car manager all cars. And first off, we can confirm that our logic is right in we should be seeing a list of all those IDs. Actually, this should go at the end. I apologize, because it needs to go after we create the car. And Tom, I think you're on a good path, and I'm gonna kind of pick up where you were going there in just a moment. But I figured we might as well run this code since we have it. And so this looks good, I think, right? Total cars. I may have modified this logic a bit actually from how it was originally. So in fact, I'm just gonna make a tweak so that I know this is a little variation on what you did, Chris, but this way we have consistency, and I think I made things a little more confusing. And now total cars matches the car ID for each one. And we can see in each car, as we create it, it's added to our list. And Tom, I think where you were going next was, hey, I want more than just an ID. How can we do that? What would we want to add to this list instead of an ID to get more information about each car?
That's exactly what I was thinking.
Yeah, and you can phone a friend if you want. What can we put here instead of self._ID? So we can get all the information about the car.
Can we just put self?
As self.
Yeah, we absolutely can. And we haven't seen this that much yet, and this is like the power of self and the power of classes and class instances. Self represents this particular class instance. And let's see what happens now when we run this. So this looks what we want. And can someone remind me if when I print this out, instead of seeing this main.carManager object at blah, 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 if I maybe wanted to see like the car ID, make, and model, how could I do that?
Would you use the dunder string?
Very, very close. For most things, we would use dunder string.
Would it be that reproduce method?
Yeah,
dunder
it's
reproduce?
It's the reproduce one. And this is where it's a little bit more of an edge case. And I'll just make this REPR for now, which is sort of like string on steroids. Like string works for print statements, but not when we have this inside a list and we're printing the whole list. And REPR is short for reproduce. And it would help if I did self._ID there. And there is no self.make or model. So in fact, I'll just leave that stuff out right now because it doesn't exist. And there we go. We've got our cars printed, and the dunder string method absolutely is useful as well. And it would look like this. And in fact, a nice pattern is for reproduce, maybe we just use the string method, so we only have to write this in one spot. I suppose you could do it the other way around if you wanted. But yeah, this was awesome. And Tom, thank you. Great job, man. What would people like to see next? I don't want to build out the whole thing, but I do want to make sure that this is a useful time to dig into these concepts. And I also want to see what questions people have. What's on people's minds around how we're using class attributes here? Okay, cool. Does someone maybe want to navigate me through adding make or model? And then I think that's probably a good point to call it. And then we can look at class methods, which are super cool. So would anyone like to do a little navigating to help me build like maybe make and model and adding that to our car?
I can.
Crystal, was that you?
Yeah.
Yeah, that'd be awesome. Thank you.
Okay, so in your initialize function, under, I guess it doesn't matter if you put it under the car manager or before it.
It doesn't matter.
Right, first in the top, you're gonna put make, comma, model.
Yeah, we need to pass these as arguments to we need to update our function definitions, so it takes these extra arguments, make and model. And then I think you were going.
Yeah, self.make equals.
Yep.
Yeah. Well, yeah, you put model, but.
Oh, thank you so much. That was my bad.
And then self.model equals model.
Yeah, and great question about does it matter what the order is? And it does, here it does, right? Because we care about when we update total cars, but here it doesn't because these are completely independent of those things.
Okay.
And now that I've added this to my dunder init method, what's the next step to make this real and use it?
You're gonna make an instance.
Yep.
That way you mean? Okay. So in your car 1 and car 2, you're gonna add. Yeah,
Yeah,
you're gonna add a make and model there.
What
So
kind of
like,
cars do you want?
maybe like Jeep and then Wrangler.
Love it. How about for car 2?
You can do Honda and Civic.
Okay, and we've got 3.
Yeah.
I have a Jetta, so I'll throw that one in.
Cool.
What do you want for car 4?
Chevrolet. Silverado.
Love it. All things, I watched that movie the other day. And let me go ahead and run this code to make sure that I don't have any typos. But I think this looks good. We're not seeing this when we print out the lists. What can I do so that when we print this out, we see the car make and model?
Make another method. Is that what you mean?
Well,
Or are you
so
want to like call on them specifically?
so right here on line 25, I print car manager.allCars.
Mhm.
And all cars is this list that we're adding each instance of the car to. And
Do you want to see it in that?
I do.
Okay, so then you would update the I forgot what you called it. The one under the string dunder.
Yeah, the RAPR, you're absolutely correct. I have it actually calling the string method. It's a little an extra step
Oh.
because I use this, which actually calls this.
Oh.
Yeah. Otherwise, you would be right. If it was like this, then that is absolutely what we would update. I sort of added an extra layer, so we want to update the string method here.
Okay, and then after that, you could just add make. And then with the curly braces, yeah, self dot make,
Yeah.
and the same thing for model.
Awesome. And let me go ahead and run that code and make sure that works. Yeah, there we go. Awesome. Yeah, thank you, Crystal, and great job. Yeah, and do folks have any questions?
So I actually have a question about the services, and I know it didn't specify in the assignment, but the way I set mine up was just with an empty list in the init function, and then I just added a function to add the services by itself. Is that how we should do it, or is there a way to like pass it in with each instance? I was trying to do it that way, but I couldn't figure it out. Since we wanted it as a list, I couldn't figure out how to pass a list in an instance.
So did you have something like this, you mean?
Yeah, and then I created a method of just add services where you're just appending that list.
I take it that looks something like this, where it's self
Dot services dot append.
append. Yeah.
Yeah.
Let me take a quick look and let me put this below these sort of other methods here. Let's see what it says. A list that will store all the services done to the car. So it does say, let's see, implement the constructor init to initialize the instance attributes. So I think it does want us to be able to pass in services when we construct a new car. I think you're right that we also want to be able to maybe add a new service. So if I did this, how might I then, like, if for car one, I wanted to give it some, like, if the car already had some services done to it, how could I pass that list of services in the constructor? And you can phone a friend, as always, if you
Yeah,
want.
I need to phone a friend because that's what I couldn't figure out on my own.
Okay, who do you want to phone?
Does anybody know how to do it? Anybody want to volunteer?
Could you like create a list of services before you call the constructor, just like in a list, you know, service 1, 2, 3, and then in the constructor pass that in as like the third argument?
So, yeah, good news here is I think, because I know we've been covering a lot of ground today, I think we just may have seen this as more complicated than it actually is.
Okay, so I tried to do it that way, but mine kept throwing errors.
I would have to see the specific errors to be able to help debug that issue. But with this self dot underscore services equals services, let's get rid of that. So I'm gonna get, so we're gonna get some code that works and some that fails. Right? And the first car works, but then because I've added this to the constructor as an argument that I'm not passing, as a positional argument, Python throws an error. So I am going to be lazy and or efficient and turn this into a named argument with a default value of an empty list. And then that way, for all these other times when I create a car, I don't have to pass services, and it will use an empty list as a default value.
Okay, I was trying to do the brackets underneath and not in like the actual parameters piece. So I guess that's where I went wrong.
I think I understand. I would have to see it. You mean over here?
Yeah, instead of doing it up there, I was doing it under there, below that where you have self.services. And I was putting it as a list there with the brackets.
You mean like that?
Yeah,
Yeah, that's creating a list with whatever services is inside of it. And it will totally depend on what you pass as that argument for services. For car 1, this would create a nested list then, which is not what we want. For car 2, because we are not passing any argument for services, Python will throw an error. And this error is missing positional argument services because we have a method that takes these arguments, but we are only passing 2 of them instead of 3. And so that's the root cause issue there.
That makes
So yeah, if I did this for everything, or whatever I wanted to put in there, it would work fine. But yeah, the best way to do this is set a default value by using a named argument and set it like this.
cool, thank you.
Totally. Tyler, yes, sir.
I don't know if maybe I'm lost or I just missed something, but I'm kind of confused as far as like the logic of updating the total cars and the car manager class attributes every time init is ran. Like every time you initialize a new instance. Why? I guess my approach, like I was trying to figure out how you would, like the add car function, like the README talks about, of like if you create another instance of a car, it's automatically updating that object. You don't have like any control. And I'm also kind of confused on like the string and the RE part, like the dunder methods of like what made sense to me for like the total car or the all cars list or object would be either like, a 2D list where each car is its own list with all its attributes. So I was curious of like how you would do that because it's just returning a string.
Remind me at the end of the class and let me come back to those later.
Okay.
Yeah, those are good questions. I unfortunately I can't give them the time they would need to dig into it right now.
Okay.
And actually, folks, if you could please throw questions in the either our Slack channel. I think the Slack channel would be better. I'll circle back to them later, or if someone wants to make a questions doc. I do want to switch gears so we can look at method attribute or class methods, excuse me, and build out some of that stuff before we wrap up. So why don't we let's take 5 and have it be a real 5, and then we will come back and we'll see what class methods look like. So we've looked at, and in fact, I'll come back to this, the curriculum doc later. We're familiar with creating a class and using a constructor. And it would help if I was sharing my screen, wouldn't it? All right, can everyone see my screen, and is it VS Code? Awesome. Glad I caught myself there. We're familiar with creating a class that has a constructor method, and we create a class instance method that we can call for every new instance of this class that we create. And we learned about class attributes, right? Where if maybe I feel like the value pi is something that's useful for all instances of this class to have, and that doesn't really belong to one specific instance of the class, I can create a class attribute. What we can also do is create class methods. And for this, let me, in fact, create another class named rectangle, because this will be, I think, be useful to see. And it's going to have a dunder init method. And since it's a rectangle, we're going to want to know the width and the height. And we're going to do all the normal things that we do of creating instance attributes or instance variables. Right, and we might want to calculate area method. But we can get there. So I can create a rectangle. And this would be like a very wide rectangle. And this would be a skinnier rectangle. And this would be a square, right? And what if I want to make it really easy to create a square? Because that's sort of like a special kind of rectangle. There are a couple ways to solve this, but one is with what's called a class method. And this uses a decorator named class method, the same way we use the property decorator to create getters. And in fact, if we hover over VS Code, we get a really nice description here. And the most important part of this is actually this first sentence that was hiding. A class method receives the class as an implicit first argument, just like an instance method receives the instance. This lets us do something really interesting. And I need to put COS, which I'll use as short for class. And Python, just like Python handles passing self as an argument for instance methods, Python handles passing the rectangle class for rectangle methods. So this lets me call this class's constructor. Um, right, and let's make an instance method of let's just make a dunder string method. And it'd help if instead of side one, I said with. I'm just going to put rectangle 2 and square there so we can see this. And so I can see that this class method creates square lets me standardize certain things. And Michael, yes, the class method lets you call the constructor. And that's what this CLS is short for. So like what's happening here is think of this as the class name, right? The class definition, not an instance of the class, gets passed in as an argument. So for us here, this is rectangle. actually, so this is the exact same as this right here. Actually, I'll put it over here to the side, which is probably easier to read. And let me show another example of this, maybe with our dogs. Let's open up. Is it in class instances that we have the dog? Yeah, let's grab our dog class. And let's say for the dog, we want to be able to create different breeds of dogs more easily. And maybe we're going to make a poodle as well. Oh, and I'm so sorry. This should absolutely be named. Otherwise, all Labradors will be named Fido. And let's go ahead and does our dog, well, we have a describe dog. I'm going to use that in my dunder string method. We'll just do def str self, and we'll return self describe dog. And so now I should be able to print out Fido and Arthur. And I should have, hopefully, a Labrador Retriever and Poodle. So the class method lets us call the constructor for that class. And that's what this CLS argument is that Python passes in for us. And it lets us do all sorts of interesting customizations. This is by far the most common use case where like you have a pattern of things that you will often want to create. Or like we saw with the rectangle, it makes sense that we want a class method to create a square because a square, the sides are the same. So I don't want the potential for different width and height arguments. So I can write a class method to do that for me. So this is a great example of a good use case for the class method. So I just want to check in and see what questions folks have about class methods. And Kara, yes.
Yeah, so I just had a quick question. So with the class method, you're talking about using it primarily to like pass things through the constructor. But what about things that like if you wanted to have methods that were the same for every instance, but using class like class variables or class attributes. So like because otherwise you'd be calling it, if you were to call on it, if it was a instance method, then you'd have to like call on specific instances when you're calling it, say like I don't know, whatever it was, like poodle, whatever your method is, as opposed to like dog dot whatever your method is.
Well,
does that make sense?
I think so. Let me actually move this here. So to answer your question, the class method, really what it does get you is that you get the class name passed in and you can call the class's constructor. That is definitely its big advantage and what it's most often used for. I think you're asking about like a method that would be same for all instances, but use class attributes. And that's sort of what we have going on here with how many legs, right? Or species. Like we can use class attributes within our instance methods, no problem. Is that sort of what you were asking about, Kara?
Yeah, pretty much. I guess I was just trying to say, like, if you wanted to call it outside of the class for whatever reason,
Right,
instead of having to call on any specific instance,
right,
you could call on the class method itself.
right. Absolutely. And there is, so you could use a class method for that if you wanted. But what there also is something called a static method. And I think that is maybe a better fit for what you're talking about, though there's a couple caveats that go along with that. Like, for example, for, let's see, let me think about for a dog. Like, let's say we wanted to get information about like all dogs generally, like maybe the dog species and the number of legs or something like that. I could write what's called a static method. And that would look like this. And let me put this up here. And we would use the static method decorator. And let's call this just maybe animal info. Dog species, number of legs. And let's go down here to where I'm doing all this stuff with dogs. And let's print dog. Let's call this animal info method. And so if I want to create a method that is not tied to a specific instance, that's part of the whole class, and that doesn't relate to instances at all, I would use a static method. Because what you can't do here is like access instance variables and stuff. Like this should throw an error. And in fact, I've already got this squiggly here saying self is not defined. I can pass self as an argument, and fingers crossed we're going to get an error from Python. Yeah, so missing one required positional argument self. Remember, like whenever we call instance methods, Python takes care of passing in self. Static methods, they're called static because think of it like the class is static. There's no instance with possible different stuff that's been created. Static methods don't have access to self, and that's by design. So depending on what you want to accomplish, you might be able to do what you wanted with a static method. But if you need to like grab like instance attributes or stuff like that, then you probably just want to create a normal instance method. And those are sort of the bread and butter. These are more like special cases type things. Like another good example of an instance method is, let me make a new file here. Or excuse me, another good example of a static method is, let me just kind of code up this example from the lesson. And this is a really common use case for static methods. And I'm borrowing this code from today's lesson, so I'm not going to go into this too much, but we're just sort of like cleaning up the text. and making sure everything's lowercase. And like, if like this is actually a good trick because every now and then this pops up in technical interviews or programming problems. A palindrome is a I can't remember one off the top of my head. But like a
Race
word,
car?
what it?
Like race car?
Yes, thank you so much. Perfect. A word that reads the same both ways. And like the best technique and a classic technique and a good one to know because it might pop up in programming problems is if you reverse a string and compare it to itself, that's how you can test if something is a palindrome or not. And this is a little bit of Python list fanciness that does some reversing. So maybe like over here in my other file, I want to import this string utils directory, and I don't know why, but maybe we want another static method that does something like add exclamations. And whatever text we pass, it does this to it. And so sometimes you might have like utility classes with a bunch of static methods. And now like I can import this and anywhere I want, in string here, I can do, print string utils that is palindrome race car. This is a good example of when you might do a static method. Here, calculating the area of our particular circle, right? You wouldn't want this to be a static method because we need to access self.radius. Crystal, yes.
So would like the math functions that we use, like math.floor and stuff, are those like static methods?
Yeah, I think they are. That's a great example. And here I'll close this one out for the moment. Because Crystal's saying like, hey, what about like math.floor of 3.141? And in fact, if we hover over, do we have to import? See if it says it.
I think you just gotta import math.
Yeah, it's part of the standard library. Thank you so much. Okay, it's not giving me a lot of interesting info, but if we pull up and we go to the Python docs, let's find floor. And it isn't telling us here, but yeah, 5 gets you 10, that it's a static method on math. I think you're right, because indeed the way we do it is class name dot method, and we don't have to create any instance. And I'm like 99% sure that this is a static method. And this is a great example, Crystal. Thank you so much for mentioning this. Like you can see how this is useful when you're say like building Python, because you can create a math class, put all this useful stuff on it, and then you only have to import one thing. And you could imagine too with like circle, like maybe we want a static method named something like calculate diameter if we give it a radius. right? The diameter is twice the radius. And this is kind of a made up example, but trying to illustrate, well, like sometimes maybe I care about the diameter of the particular circle I'm dealing with, an instance of a circle, but maybe sometimes I just want to be able to, for any given radius, calculate its diameter or something like that. And you can call static methods anywhere you want. For instance, if for some reason, if I did want to do this, you know, to be honest, this doesn't make a ton of sense, but more to illustrate the example. And real quick, I do want to refer to just to very briefly kind of walk through some of our recommendations on how to use these things. And these are good guides. So instance methods, right? The ones that you're used to that take self as an argument, where you can access all those instance attributes. These are your bread and butter. When in doubt, just make an instance method. And most of the time, there's always going to be at least two or three ways to do things. Sometimes there's one way that clearly offers advantages. Sometimes there might be multiple equally useful options. In general, go with instance methods, and this is what you use for most stuff. Again, this idea of encapsulation, and all our instances have the same instance methods, but this lets us figure out stuff for, you know, specific things. What's the area of this particular circle? What's the name, the full name of this particular student? And the calculate area of circle is a good example of this. Class methods are for the class as a whole, really creating alternate constructors, like you all saw with my example, since that's the class name gets passed in, is by far their most common use case. You probably won't be creating class methods very often, but this is a great example of what they can be good for, is alternate constructors and sort of consolidating that. And that actually can be super useful because it lets you write your dunder init method with a whole bunch of stuff, and you can even give it defaults. But as your programs get more and more complex, you'll run into more and more cases where this might be useful. Static methods, if anything, you might make static methods a little more often than class methods. But again, you don't use these often as well. Utility functions is sort of like their classic use case, sort of like with class, in some ways like with class attributes. They're useful for code organization and for readability. Sometimes it's just easier to import a class that has a bunch of relevant static methods, like Crystal, like you pointed out with the math class. Like I can just import the whole class and get everything I need on there. In general, honestly, I would say the most important thing is following the single responsibility principle and the idea of separation of concerns. Think about what you want your method to do and try to have it do one specific thing, and then choose a name that clearly illustrates what it does. And you usually want a verb in the method name so that it's, you know, like get this or do this or calculate this. If you don't have a verb in your method name, that actually is maybe a signal that you need to think more about what you want this to do. And most of the time, you're going to be making instance methods. Readability is super important, and it actually helps you reason about your code better and understand it better. Taking the time to think about good variable names and method names, I think, is really important. And again, methods are great for encapsulating logic that get used in multiple places. And we do have a couple of sort of like recommendations of best practices around class attributes as well versus instance attributes. So let me just quickly go over that. Instance attributes are, again, gonna be your bread and butter. You're gonna use these most of the time when you're creating classes. And I think these examples are pretty straightforward. It's things that are specific to a particular instance, right? And there's nothing wrong, by the way, with like a really small class. like to go all the way back to our exact change problem. And I don't know what value. You know, and I might do. And I'm making this in all caps because I want to tell other programmers this instance of the denomination class should never be modified. Python doesn't have a way to define like real immutables or constants. So we need to indicate our intent to other programmers. And there's nothing wrong with a simple class that doesn't do a lot, because this actually is kind of useful. And now I also get great type completion and hints from VS Code, which is one advantage over dictionaries. So that's really nice. And I think I showed this example the other day, but if not, to build on this, right? And maybe what I want to do here is in fact, maybe I want like amounts. Maybe this is going to be a getter. And I'll use the property decorator for it. And now I can do something interesting, like if, you know, amount equals 1, return an F string of self amounts, self denomination, singular. VS Code isn't quite smart enough to, I think, get nested this way because it doesn't have the type hint. And this needs to be self underscore. Else we return plural. Right. And so my classes follow the single responsibility principle. This class's only job is to hold information about denominations. What is a quarter worth? How do I say what a quarter is? This class's job is to hold amounts of money, and we compose with this other class. And I have this one getter right here, because now I can do, you know, $5 equals amounts and 5 and quarter, and I can do $5 dot get amount. And I could have made this a method if I wanted, but I want to just illustrate getters. And as someone pointed out, you know, once you start shortening the names, it does start to become more useful. So instance attributes, encapsulating, a lot of this is your bread and butter. Class attributes, less common. Shared information, total cars, all cars, and constants. And stuff that's static, which is similar to constants. So class attributes you use less often, and sometimes you might not want total cars as a class attribute or all cars. Sometimes you might want that as a separate list, not attached to any class, or you have a separate class, and that's going to be a design decision. But as always, I think the rule of thumb is like simplicity and clarity. You know, for the assignments and the assessment, sometimes we will want you to do things a particular way. And very often that's to help like flex and practice using some of these techniques and skills. So I know I've covered a lot of ground and we're also 10 minutes past lunch. So I do want to have a break for lunch, and then I'm happy to tackle a couple questions. Let me just go ahead and stop the recording.